primary alcohols can be converted to alkyl halides using a strong hydrohalic acid. And so the strong hydrohalic acids we can use are HCl, HBr, or HI. With a primary alcohol, the reaction mechanism is an SN2 mechanism. And so that means that the substitution itself takes place in one step, and it requires a really good nucleophile. So with these three hydrohalic acids, bromide and iodide are really good nucleophiles. Chloride's okay. So it's not as strong of a nucleophile. And so with HCl and a primary alcohol, we add in an additional catalyst. And so we add in zinc chloride when we look at the reaction of a primary alcohol with HCl. So let's take a look. I'm going to do two examples. We'll do one first with hydrobromic acid. So if we have a primary alcohol, so something like ethanol, and we react this with hydrobromic acid, the first thing that's going to take place is the acid-base reaction between the alcohol and the HBr. So this alcohol oxygen is a good base. It's got lone pairs of electrons, and so it will react with the HBr. So it will attack and pick up that acidic proton. And what this first step does, this is kind of a pre-step to the substitution reaction, is we're adding an extra hydrogen to this oxygen so that it now has a positive charge. And so what we've done is we've taken and converted a really poor leaving group, because the alcohol, this OH, if it were to leave, it would leave as hydroxide, which is too strong of a base. So we've converted that poor leaving group into a good leaving group. And now the halide can attack that. All right, so here is our halogen, and this is a good nucleophile, and it'll attack the carbon atom that the leaving group is attached to and break that bond. And so in doing this, what we've done is we have taken and converted an alcohol into an alkyl halide. In this case, an alkyl bromide. And so we might want to do this if we want to do further chemistry on this structure. The halide ion is a good leaving group. It's a lot more versatile. And we can use that then in further substitution or elimination reactions. Okay. And so the second mechanism I want to show you is I'm going to take the same alcohol. I'm going to react it with HCl and the zinc chloride so we can see what it is that the zinc chloride is doing in this reaction. Okay, so here is an alcohol. And so if you have HCl and zinc chloride in there, it's going to react with the zinc chloride first. So the zinc is a really good Lewis acid catalyst. So that's what the role here is, that this is a Lewis acid catalyst. And so we're forming a Lewis acid base complex. So this oxygen is attacking the zinc, and it's going to lose one of those chloride ions. And so what we have then is our oxygen. It still has a bond to hydrogen, and it also has a bond to zinc, which has a bond to chlorine as well. And so what we have then is a positive charge on the oxygen, much like this one. But by having the bond to the zinc, this is actually a better leaving group. So the nucleophile is going to be the chloride ion, which we said isn't as good of a nucleophile. But if we want to substitute a chlorine, we have to use chloride as the nucleophile. We can't change that. We can't make that a better leaving group. So we manipulate this reaction we can't make the chloride a better nucleophile, but we can make a better leaving group, and so that's what we're doing here. So this is a better leaving group. And then this can be displaced by the chloride ion, which is a relatively, it's an okay nucleophile. It's just not as good a nucleophile as bromide or iodide. So it'll do the SN2 attack here. And so overall, we are still forming the alkyl halide. And we've got the zinc salt in there as well. I'm not going to draw it. I'm going to focus just on that major product. So we're still taking an alcohol and converting it into an alkyl halide, which again, the alkyl halide can then undergo further substitution or elimination chemistry if there's something else we want to add to this molecule.